afternoon, Year 12s. I'm just going to do a quick review of some of the topics that you need to know about ocean acidification. The first thing I'm going to talk to you about is pH. And we know, of course, that pH is a measure of the acidity of a solution. So in this case, the acidity of our ocean water. And it is a measure of the concentration of hydrogen ions. So these square brackets, for those of you who are not chemists, the square brackets mean concentration. So the pH is a measure of the concentration of hydrogen ions. It's really important that you know that low pH, so if we've got low pH and high pH, so pH goes up to 14 and it goes down to 0 or 1. In the middle we've got neutral. What I want you to remember is that these low pH here is acid, and these high pH, the opposite, is base. So these low pHs have a high concentration of hydrogen ions, and the bases have a low concentration of hydrogen ions. It sometimes seems counterintuitive because we're talking about, when we're talking about ocean acidification, we're talking about a movement in this direction. So downwards is becoming more acidic. And when it becomes more acidic, it does increase the amount of hydrogen ions. So that's the first thing that we need to know about. There's a couple other things. Let's think of some examples of things with low pH. So we might think of lemon juice is sort of in the middle there. I think it's 3 or 4, isn't it? Maybe hydrochloric acid is a very strong acid, so it has a very low pH. Neutral would be water. Something which is basic are some maybe like soap or cleaning products. And then the one which is really important to us is seawater, which is about pH 8.1. So it's a little bit basic. So there's our first, that's our first concept. All right, the next thing I want to talk to you about are the ions in seawater. Okay, so, wow, we have to change it to black. That helps, doesn't it? Okay, so there are lots of different ions in seawater. This is what makes the seawater salty. So, of course, the ones, when we think about saltiness, we think about sodium and chloride. But there are lots of other ions in the ocean. So we've got, for example, magnesium and calcium, and there's carbonate ions, lucky for the coral, and there's also something called bicarbonate ions, and then there are, say, there's sulfate ions, and so on. There are many, many different ions. My question to you is, how did these ions get into the ocean? And there are two main ways. The first way is from interactions with the seafloor. So we're at the seafloor. So here's our ocean. We put a little bit of land. There's our ocean. So here at the seafloor, there's some sediment there, some minerals, and very slowly over time, these minerals dissolve into the ocean, and that they give us some of these ions. The second way is through a much, well, they're both slow processes, but this is also a slow process, is the water cycle, but I'll just call it a geochemical cycle. All right, and this takes hundreds of thousands or millions of years to progress. So what happens is we've got some land here, and then there's the ocean. Of course, it rains on the land, rains on the ocean as well, but we don't care about that for now. Rains on the land, and erosion occurs here. So into this rainwater, some minerals are dissolved, and those minerals move down to the ocean through runoff, so in rivers and just running off into the ocean. So each time it rains, a tiny amount of these ions is dissolved in that water and gets added to the ions in the ocean. It is a tiny amount, but every time it rains, and this process happens over millions of years, a tiny amount is added each time. But why then does it accumulate? The reason it accumulates is because the water then evaporates. This is where we're talking about the water cycle. It evaporates into a cloud, and then, of course, that's our water cycle. Precipitation, runoff, evaporation, and then just movement of the water. In this evaporation evaporation out of the ocean, it's only pure water which leaves the ocean. All of the ions are left behind. So you can see all the time the ions are being replenished by runoff, and the water is leaving. So slowly, over millions of years, these ions and the other ions that are present, dissolved minerals that are present in the seawater, have accumulated over that long period of time. So this is all fine and dandy. The sea is really quite stable in its chemical composition over that sort of time scale. The problem arises is that we humans have come along and we've started to do things on a much quicker time scale. So we're putting pollution into some of the runoff that's happening here, but of course the biggest problem that we're talking about is carbon dioxide into the atmosphere. All right, the last topic we're going to address is ocean acidification. And when we're talking about ocean acidification, we do not mean that the ocean is becoming acidic. Rather, it's just becoming slightly more acidic than it used to be. So if we remember our pH scale from 14 to 7, I beg your pardon, 7's in the middle, our seawater's about here. So it's not becoming acidic. It hasn't passed the 7, but it's just moving more in that direction. This ocean acidification is caused by carbon dioxide. Carbon dioxide from natural sources, but primarily from anthropogenic sources. So the carbon dioxide is dissolving in water, and it's forming a substance called carbonic acid. All right, so you don't need to know these formulae if you're uncomfortable with them, but for myself, I think learning these equations helps me to understand it better. So you can see that this carbon dioxide which just dissolves in the ocean from the atmosphere. It reacts with the water. You can see this symbol here is a little double-headed arrow, which shows that this equation is in equilibrium. Some of the time it goes in that direction, and some of the time it goes in that direction, depending on the concentration of the substances. And it's forming this substance here, which we call carbonic acid. Remember that an acid is formed because of hydrogen ions. So you can see that there's a couple of hydrogens in this carbonic acid. So let's have a look. We'll just ignore that top equation for the minute. We'll have a look at what is happening to carbonic acid and where the hydrogen ions are coming from. So carbonic acid itself breaks down in water, or breaks down in solution, to form some other substances. So this first thing, you can see this hydrogen ion here. That's not very red, is it? this hydrogen ion here, that's our first little bit of an acid problem. This ion here is called the bicarbonate ion. And this ion, you've got some bicarbonate in your pantry, or sometimes it's called bicarb soda. And if you taste it, you can taste that it's a little bit basic. Okay, this bicarbonate ion. So this is why the ocean is a little bit basic. But we're not finished yet. This bicarbonate ion can break down further into carbonate, and then that's therefore adds another hydrogen ion. So you can see here that we're actually got a fair bit of hydrogen ions being produced initially from this carbon dioxide that is dissolving into the water. So I'll just relabel those. Remember, this is carbonic acid is our first one. It dissociates or separates a little bit into carbonate ion, which this carbonate, beg your pardon, did I say carbonate? It's bicarbonate. The bicarbonate ion then dissociates again into a carbonate ion. This is why carbon dioxide is causing ocean acidification.